In this video, we will talk about how to solve this GMAT question. A dataset A, all x, satisfy an equation, find median. Let's look at it in the highest level first. For the time being, ignore the ugly looking equation. If we can find all the x, supposedly this list of number, then we can easily rearrange them in ascending or descending order. Find the middle one, that's the median. Then we are done. So the whole problem is now narrowed down to how to find all the x. Now we turn our attention to the equation. Observing the equation, it's quite obvious that we can use chunking, grouping some parts together as one single object. This equation is in the form of a to the power of b equals to 1. Now others will teach you that there are exactly 3 cases for this to happen, namely these 3 cases. But I think I should explain a bit more so that you can fully understand. But before I begin, let me remind you that this is a deep dive version. You should not spend time doing deep math theory deduction during exam. Now we'll look at this prep question. Find all number x that satisfies this equation. Now in the form of a to the power of b equals to 1, we have a special name for a and b. A is called the base, and B is called the exponent, sometimes index or power. I also want to bring your attention to the right-hand side. The number 1 is not arbitrary. It's a very special number that plays a central role in our journey. Now in this prep question, the base is fixed, and we can use chunking. Let's pay attention to the graph that we all know. For A equals to 3 and different values of B, we can plot the graph. And a graph is a strictly increasing function which only achieves a to the power of b equals to 1 when b equals to 0. Now let's solve this. Our chunk equals to 0, x is minus 1 or 2, done. And now we have all the x we need. Let's look at the second prep question. Same thing, find all x. This time the exponent is not changing, the base is. For different values of the base, we divide it into 5 cases. A greater than 1, a equals to 1, a between 0 and 1, a equals to 0, and a smaller than 0. We treat this case by case. Case 1, a greater than 1, then a to the power of 13 will be much greater than a, and thus greater than 1. Case 2, a equals to 1, then a to the power of 13 will be equal to 1 to the power of 13, which in turn will be 1. Case 3, a between 0 and 1, then a to the power of 13 will be much smaller than a, which in turn will be smaller than 1. Although a to the power of 13 will still be positive, it will still be greater than 0. Case 4, a equals to 0, then a to the power of 13 will be 0 to the power of 13, which will be 0. It's not 1, not possible. Now case 5, if a is negative, this case is quite interesting, because it's a to the power of b is actually undefined if b is not an integer. But if b is indeed an integer, then a to the power of b will be negative if b is odd. It will be positive if b is even. And this also tells us that a to the power of 13 will be negative, which in turn will be smaller than 1, not equal to 1. Collecting all the results, we find that case 2 is the only possibility for a to the power of b equals to 1. So now we know the only possibility is x squared minus 1 equals to 1. No other possibility. Solving the equation, we could get x equals to root 2 or minus root 2. And that's our solution set. Now let's turn to our prep question 3. All x satisfying the equation. This time the base is fixed to be minus 1, which is a negative number. So again, the left-hand side is only defined when x, the exponent, is an integer. But if x is odd, then minus 1 to the power of x will be minus 1. It is not equal to 1. And if x is even, then minus 1 to the power of x will be equals to 1, which satisfies our equation. Pay attention again, when we say even number, it includes all the positive even number, 0, and all the negative even numbers. Sometimes this set is also written as 2z, which is an infinite set. It has infinitely many elements in there. Now prep question 4. Do you agree that x squared plus 16 is always greater than 16? At the outlook, it seems to be true, but actually not. Not when x equals to 0. So x squared plus 16 is not always greater than 16 itself. But x squared plus 16 is always greater than or equal to 16. That's what's always true. We want to find all number x such that it satisfies this equation. Now the equation is still in the form of a to the power of b equals to 1, but this time both the base and the exponent are changing when x changes. From previous question, we learned that x squared plus 16 is always greater than or equal to 16, and thus is always greater than 1. So now let's look at the whole expression on the left-hand side. The insight we need here is that x squared plus 16 being a number greater than 1, the only way for a power of it is 1 is when the power itself is 0. And that when the power itself is 0, the actual number of x squared plus 16 actually doesn't matter much, except when it is 0, which is not happening for now. Therefore, the whole equation can be simplified as x plus 1x minus 7 equals to 0. That's the only possibility. It is a sufficient and necessary condition. And solving it will give us x equals to minus 1 or 7. Then we are done. Now prep question 6. Same setting, all numbers satisfying the equation. But this time, the exponent itself is always positive, because it is 2x squared plus 68. This guarantees that if the base x is greater than 1, it is not possible. Same is true for the base x to be between 0 and 1. It's not possible to have a positive power to make 1. What if the base is actually 0? Then the whole thing will be 0. Even 0 to the power of 0 is not 1. 0 to the power of 0 is undefined. So we are sure that x equal to 0 is not possible. Now we can use the same logic to rule out every other number, but leaving x equals to 1 and minus 1 to be the only possibilities left. When x equals to 1, there is actually no restriction on the exponent. And when x equals to minus 1, the exponent must be even, which in this case it is. Or just to be sure, we check this way. 2 to the power of minus 1 squared plus 68 is actually equal to 70. It is even. So our solution set is 1 and minus 1. Now this is our last prep question. All x satisfying an equation. Now we combined what we have learned. There are 3 cases. Case 1, base equals to 1 and exponent no restriction. Case 2, exponent 0, base not equal to 0. Case 3, base equals to minus 1 and exponent must be even number. So for case 1, we have x equals to 0, and because the exponent has no restriction, we don't need to worry, we accept it. And for case 2, it's also x equals to 0, and we can check that 3x plus 1 is actually non-zero, so we accept it. Why would there be 2 cases giving us the same value of x? It's because if you plug it in, you can see that it is actually 1 to the power of 0 equals to 1, which makes absolute sense. So this expression equals to 1 for 2 very important reasons. It's both base equals to 1 and exponent equal to 0. This is not a special case, it's just a stronger, even stronger case for this whole thing to be 1. And now the third case, we have x equals to minus 2 over 3. But when we substitute this number back to the exponent, we can see that it's not an even number. It's not even an integer. So we have to reject it. Now I think we are finally ready to tackle the original problem. We just split it into 3 cases. Case 1, base equals to 1 and exponent has no restriction. So we have 2 solutions, 0 or 3. Case 2, exponent being 0 and base is non-zero. We have minus 1 and minus 9. Substitute back into the base and we can check that it will not give you 0. Then we accept both as parts of our solution set. Case 3, base equals to -1. We have two possibilities, 1 and 2. And don't forget to put it back into the exponent to check if the exponent is actually even number. And we need to reject one of these. Now we have our whole solution set, and we can rearrange it, and we can extract our median. Then we are done. The answer is B. So how do you remember these three cases? I would suggest you to remember these two very easy formula and from there extract what you needed as you go. I think these three circles correspond to our three cases. If you can relate, then you don't need to remember that much. You just need to remember these two very easy formula, extract the information you need when you need it, then you are done. I hope this video can help you in the preparation process of GMAT. If you have any opinion, suggestion for improvement, you are very welcome to comment below. You can also consider to like, subscribe, or share the video to those who may need it. God bless you.